Now coming to the second characteristics of the sound, we'll be having the second characteristic now, that is pitch or shrillness of the sound. Students, pitch is that characteristic of sound by which an acute or shrill note can be distinguished from a grave or flat note of the same loudness. Now, students, we are keeping the loudness constant, but still we will be having two different sounds, that is shrill or flat. Now, students, you must have done the sargam, that is also known as notes in music, that is sa, re, ga, ma, pa, dha, ni, sa. So if you recite it in form of music, then your first three notes, that is sa, re, ga, they are flat notes. They are flat or grave notes. While the last three notes, dha, ni, sa, are shriller notes. They are also known as sharper notes. So students, pitch is the characteristics of the sound by which an acute note can be distinguished from a grave note of the same loudness. Now, students, note that if the pitch is high, the sound is shrill. High pitch means shrill sound, and low pitch is known as flat sound. Second point to remember is pitch is directly proportional to frequency of sound. That is, number of vibrations made per unit time. So what is this? This is the definition of frequency. What is frequency? Number of vibrations made in 1 second, or you can say number of vibrations made per unit time. So pitch is directly proportional to frequency. So what does it mean? It means that more is the frequency, more is the pitch, and more shrill is the sound. So students, observe figure 2a and 2b and answer me which wave is having high frequency. See figure 2a and figure 2b. Which wave? Wave A or wave B is having high frequency? So how to calculate high frequency? Listen, in this time, this is the same time, see, this T time. Okay. In the same time, whose vibrations is more? Is it of A or is it of B? Yes. Number of vibrations made by B is more as compared to that done by A. Excellent. So students, out of A and B, B will be, what will be B doing? B will be giving us high pitch sound, or you can say a shriller sound. Students, see, in both cases, the amplitude was same. That means loudness was same, but frequency is different. So wave B and A are of same loudness, but B is having more frequency. So B will be giving a sound having more pitch. Now students, I have a question for you. You have to write its answer in your physics notebook. So question number 1. If you have two different tuning fork, P and Q, where P will be emitting a sound of frequency 512 Hertz and Q will be emitting a sound of frequency 256 Hertz. Then which tuning fork will give you a grave sound and why? Students, grave means flat sound. Grave means flat. So out of which frequency of tuning fork will give you a grave or flat sound and why? Question number 2. Generally, whose sound is found to have more frequency, a man or a woman, and why? So students, I have given you a hint in the notes also. Kindly find the answers of these two questions and write down in your physics notebook. Now students, further, I want to discuss two applications of pitch. First is, as the water level in a pitcher kept under a water tap rises, the length of air column decreases, but frequency increases. Now students, kindly see the screen shown in front of you. We have already studied that frequency is inversely proportional to length of air column. Now students, suppose this is a water bottle of yours and you have kept it under the water tap. And when the water starts rising in it, see, I have shown you three cases, A, B, and C. In the first case, when very less water was filled in the bottle, this whole space, empty space, was having air in it. So this is known as length of air column. In case number B, when your water bottle is halfly filled, then the length of air column has decreased as compared to that of A. Similarly, in case C, when your water bottle is about to fill with water, then there is very less value of length of air column. Now, if you just see all these three cases and read the statement written at the top, can you make out where pitch will be more? Yes, pitch will be more where frequency is more. And frequency is more where length of air column is less. That is case C. So in third case, you will be able to hear a sharp or shrill sound. Students, you can observe this change in frequency while filling a water bottle, and kindly try this at your home and see the difference. Observe the difference by listening to the different pitch of sound. Students, similarly, in string instruments like sitar, guitar, violin, the frequency of vibrations of a string depends on the tension and thickness of the string. So in string instruments, the frequency of vibrations of a string depends on the tension and thickness of the string. Thus, a note of higher pitch can be obtained by vibrating the string under high tension or by vibrating a thinner string. So now let us start with the third characteristic, that is quality of sound, which is also known as timbre. See the spellings of timbre. It is Timbre, timbre. Quality of a sound is that characteristic which distinguishes the two sounds of same loudness and same pitch, but emitted by two different instruments because of change in their waveforms. Now students, the amplitude and frequency both are same. So same loudness and same pitch means amplitude and frequency are same. But still there is a certain difference between the sound made by two different instruments. For example, if you play a music on harmonium and if you play the same music on guitar, you will have two different sounds to listen. Now, the music was same, having same loudness and same pitch, but for two different instruments, it will be sounding different. Why so? Because there is change in waveforms. So students, a note played on a piano can easily be distinguished from the same note having exactly same loudness and same pitch, but played on flute. So to understand about waveforms, I request you all to observe figure number 3. Now in this figure, our first diagram is a curved wave. And in the second diagram, we are having a triangular wave. So students, number of vibrations are same. Even the amplitude is same. So in these two diagrams, loudness and frequency or pitch is same. But see, are the two shapes equal? No. They are two different waveforms. So the two diagrams will represent sounds of same loudness and same pitch, but different quality of sound. So further we can say that both these figures represent two different waveforms. Thus, these sounds are having different quality, though they are having same amplitude and same number of vibrations in given time, same number of vibrations in given time, that is same frequency. So students, further we will do some question answers based on these three characteristics of sound. Now students, you have to do answer number 3, 4, 5, then 16th, 23, 26 and 27 from page number 173 and from question number, also do question number 31 from page number 174 of your physics textbook. I'll be helping you today for answer number 23. Now see students, in 23rd question, the diagram below shows 3 different modes of vibrations P, Q, R of the same string of a given length. Question number 1 is, which vibration will produce a louder sound and why? Now students, see figure R. It is having maximum amplitude as compared to P and Q. So R is having more amplitude. It will show a louder sound. So question number 2, which vibration will produce a sound of maximum shrillness and why? See students, wave number 3 is having maximum vibrations. It is having 3 vibrations. Vibration 1, vibration 2, vibration 3. While Q is having only 2 vibrations and R is having 1 vibration. So number of vibrations in a particular time of P is more as compared to Q and R. That means P will be having more frequency and hence it will have more pitch or more shrillness as compared to wave shown by Q and R. Now third part, this is our important part. What is the ratio of the wavelength of vibrations P and R? Now students, see the screen shown on you in front of you. Here we are discussing 23rd C part. As we know that frequency is inversely proportional to wavelength. So if we see frequency of wave P, there are 3 vibrations. So the frequency is 3 Hertz. In case 2, for Q, we are having 2 vibrations. So frequency of Q is 2 Hertz, while frequency of third is 1 Hertz. So as asked in question, we have to find the ratio between the waves wave P and wave R. So students, further I have calculated ratios of frequency of P and R, which we have calculated ahead earlier at the top. See. So from here, I will be finding the ratio and the answer comes out to be 3:1. Now, since frequency is inversely proportional to wavelength and the ratio of frequency is 3:1, it means that the wavelength of P and wave Q will be in ratio 1:3. So students, our answer for 23rd C part is 1:3. So this comes an end to the lecture of today. Kindly go through the topics and the notes given to you and answer the questions which were marked in your physics book. Thank you, students.